So day 23, we finally meet up with the elves, but the problem is that we didn't find any star fruit in this location. So basically the elves want to plant the seeds and wait for the fruit to grow. And the strategy is basically to move each elf as far away from each other as possible, following a list of rules. And yeah, basically the idea is that each elf will look in four directions: north, south, west, and east, and decide if it can move in that direction. And after each elf makes a proposal, then all the elves will move in that direction if they can, so that they don't collide with each other. So for the first part, we want to count how many empty spots will be left after 10 rounds of this type of movement. And then for the second part, we want to find how many spots will be left after the elves move until they reach the maximum distance that they wanted to have. So for the solution, I kept using this glam library because it's more convenient than using tuples, and I parsed the input as a hash set of positions. Then I have this propose function that takes in a position of an elf and the positions of all other elves, and also the directions that it needs to check, and it returns the proposal of the current elf. So basically, the first rule is that if the current elf has no neighbors, then it can stay on its current position. Otherwise, it has to check in order the directions that it receives in the propose function. And for example, for the north direction, it has to check in the northwest, north and northeast directions. If it doesn't have any neighbors in that location, then it can move in the north direction. Similarly for south, west and east, it has to check on all three directions. And yeah, if it doesn't have any neighbors in those positions, then it can move in the specified direction. Otherwise, it has to stay on its position and it cannot move yet. Then I have this round function that simulates one round. It gets as input the elves, the directions order that they need to check, and it returns the new positions of the elves. So first I iterated over the elves and got each elf's proposal for movement, and then I wanted to build a hash map that goes from the proposed position to the list of elves that want to move there. So I've used a fold with a new hash map as the initial accumulator, and then I inserted for the proposed move the elf that wants to move in that position inside the vec. Then I went over the items of the hash map, and basically if the list of elves that want to move in the proposed location is equal to 1, then it means that we only have one elf, so the elf can move there. But otherwise it means that multiple elves want to move in that position, so we don't move them, we keep their position as it was before. And we have to use a flat map because the return type for this closure will be a vec, so we want to concatenate all the items together. And then we collect everything into a hash set, and these will be the new positions of the elves. Then for the first part we have to apply 10 rounds, so we do this on the elves, and after each round we have to move the first direction to the back of the list. So I'm not sure if you can do this in a more nice way, but I just copy the first item, then I overrode each item with the next one, basically shifting everything to the left, and then I overrode the last element with the first one. Then we have to compute the minimum and maximum values on the x and y axis, and this will represent the bounding box of the map. So if we multiply the width and the height, we get the total number of points, and then we subtract the number of elves that we have. So this will be the number of empty spots on the map. Then for the second part, we just have to do rounds until the new position of the elves will be equal to the old position of the elves. So that means that they didn't move anymore, and then we can just return the index. And at the end, we just have to do the same thing for the direction, move the direction that was used to the end, and then don't forget to update the else position to the new position. So yeah, this was the 23rd day. This time it wasn't as difficult as the previous day. So yeah, basically if you want to check out the source code, you can find it in the description, and see you guys next time.